Good morning. Let's do that again. Good morning. Thank you. I'm Matthew York with the Hydraulics Unit, and I'll be moderating for this session. Welcome to session 3 of day 2 of the pre-construction workshop. As a reminder, please continue to comply with NC State's face covering policy. Now, please join me in welcoming Dr. Hummer to the podium.
Thank you. I think you should hold the applause until you've seen what I got here, and reserve your judgment. It's a pleasure to be here with you today. Always a happy moment for me to talk about intersections. It's what I do. I have no other hobbies. I go home and think about intersections, and if I get a chance to talk with them, talk about intersections with a group like y'all, it makes for a really happy time for me. So I appreciate it. I'm Joe Hummer. I'm the State Traffic Management Engineer, Mobility and Safety Division. I was a professor for a number of years, some of those at NC State. So you wind me up, I talk in 50-minute increments. So that's what we're going to do here. But hopefully there'll be a few minutes at the end for questions and get you to lunch on time. Talking today about three-phase intersection designs. It's really, I'm trying to promote some new designs, and that's kind of what I do, and show you that there are some new ones out there, and there's a couple that look like they're going to be keepers. In fact, there's one about a half hour from now that I think ultimately we'll probably end up building more of those than we will the RCIs. I think it's going to be really popular. All right. About that one. There we go. I hope you agree. Usually, two-phase designs are the best. That two-phase, that's traffic signals. You know how many green indications we provide, and two-phase designs include the RCI, reduced conflict intersection, the median U-turn, which we have a few in North Carolina now, and the full version of the CFI, continuous flow intersection. Those are the three main ones. There's a couple others out there that get things down to just two phases. Green for one street, then green for the next street. Good for safety, good for pedestrians and bicycles, good for capacity, lot of good for progression, a lot of good features. We in mobility and safety promote them heavily for safety and for capacity and for progression, and we built a lot of them in North Carolina. So usually those are the best. However, we can't always build them, right? There's, what we'd like to do and what we're able to do are unfortunately two different things. The neighbors, the businesses, the media, the politicians, sometimes they rise up against some of our two-phase intersection ideas. Sometimes the two-phase solutions really just don't work with the demand that we have forecast. And usually that's a minor street issue, that there's just too much demand on the minor street to be accommodated by RCI or whatever else we've got in mind. Sometimes it's cost and impact. Sometimes we just don't have room for those bulb outs. Okay. And sometimes it's just, it's too new. It's too radical. There's lack of precedent. We just can't push the envelope all that far. So as much as I would like to, or maybe you would like to, turn every intersection into an RCI, we just can't do that. So the presentation today is a compromise, right? And how can we get something built, something that's better than the standard conventional four-phase design, that what I would accuse of being basically the do-nothing approach, to throw up our hands and say, well, traffic really doesn't matter. Get some of the benefits of a two-phase solution. But in cases where there's just some barrier and they're just somehow not letting us do the two-phase, maybe allow more direct movements. Maybe that's what the businesses and the media and the politicians really want, is that left turn out from the side street. Maybe it's to reduce the cost and impacts, that there really isn't good space for the bulb out, and we got to think of something else, but again, not just punting back to standard conventional. And maybe something that's in a way of a compromise to alleviate the public concerns, to get the PR back on our side. So to some extent, since I've been at DOT now, that's been a bit of my role, is to come into projects and try to find compromises. Something lands on my desk, it's usually that it's a project that's gone a bit off the rails, and hey, can we find a way, again, without going back to the standard four-phase, because we know that's the least safe and least efficient thing we can do. Without going all the way back to that, is there still a way we can get some of the safety and some of the capacity, but still get the project built, get it through? So this presentation, some of the promising three-phase intersection designs that I've seen at intersections that have four approaches. So let's caveat that right away. That's most of them out there. A brief discussion of each of the ones that I've seen. And then at the end, we'll see how our time goes, but a hypothetical example. And then my goal is to inspire you to try them. So next time you're in planning or early design analysis, alternative stage, looking for a solution up against that barrier, they just won't let us do the RCI or whatever. Here's something that maybe we can come in and make that compromise and still get safety, still get capacity, and get the darn thing built. So here's the list. 10 of them altogether. The ones on the left side are what I would accuse of being fairly common. Quadrant roadway intersection, maybe I'm stretching the definition there a little bit, but at least there's a lot of literature on that. Jonathan Reed over here and I wrote a guidebook for Federal Highway Administration a couple years ago about the quadrant. So there's literature out there, fairly common, at least knowledge of the quadrant. The partial CFI, we actually have one in North Carolina, in the Charlotte area, been open for a couple of years. And then offset intersections are fairly common. So there's those three. And then the ones on the right, 7 of them there that I would say are, at least to my knowledge, the newer ones. And those are the ones I'm sort of here to promote today and hopefully that you'll consider. There's another one out there that is fairly common. If you've ever been to New Jersey, if you've ever driven through New Jersey, you recognize the Jug Handle. It is a three-phase design, but it's really not competitive. So I'm going to raise that one and then dismiss it right away and say that we even tried Jug Handles in this state back in the 1970s. You could see some vestiges out there in Garner, and it's not shouldn't be on the list. And then there's probably some other three-phase designs out there that at least didn't make my cut anyway. So I don't pretend to have the exclusive list of all possibilities here, but at least these 10 I think have some promise and could be worth a thought on some of these projects. Here's in the next few slides. Here's how I'm going to evaluate their potential. This is motherhood and apple pie. These are all the things we should be shooting for in our projects having to do with intersections, capacity and travel distance. Number of conflict points. I wish we had good safety models for all of these alternatives. They're all new though. We don't know, but we're gonna. A number of conflict points is a pretty good surrogate, really rough early surrogate for approximately how many crashes will eventually occur. Do we need extra right of way? That's again, in early stages, a pretty good surrogate for cost and impact. If we're not touching extra right-of-way, we're probably not going to incur very many extra costs. And then the pedestrian quality, crossing quality, and signal progression capability round out my list. Again, not exhaustive. You certainly could think of other measures, but hopefully this captures a good number of them. And then this is just nomenclature. When I show you the capacity results in a little bit, I'm going to report them in terms of basically left turn equivalents. So capacity, an intersection that has 3L is not very good. On the other hand, an intersection that has 2L is darn good. That's a really excellent capacity. So that's my shorthand for the measure of capacity I'll be showing you. Okay. A little bit more on the measures that I'm going to show you. Pedestrian crossing quality. This is a document also that I've been promoting for the last couple of years. If you're interested in pedestrians, we got a session on complete streets later. These complete streets should be all over this. How do you measure whether the street is complete? Well, how good is the pedestrian crossing capability? Well, how do you measure that? Turns out we've got a good measure of that. That was in NCHR report, NCHRP report 948, the so-called 20 flags method of judging the quality of a pedestrian crossing. So I did that for all of these intersection designs, and I came up with a weighting. There's in this method, there's yellow flags, which are uncomfortable moments for a pedestrian, and then there's red flags, which are more unsafe things for the pedestrian. And I weighted the red flags twice as much as the yellow flags to come up with one score. But if you're in the business of at all thinking about pedestrians on your streets, 948 should be really central to your work. All of us doing this kind of work should be using 948 at this point, the 20 flags. And then as far as progression goes, a real basic time-space diagram kind of thing that you probably haven't seen in a number of years since you were back taking my class. But here it is, it's back again. And what I'm boiling it down to is the key question, how much time does the minor street need? And that's basically in white there. This is a example from Belmont, North Carolina. And you got two minor streets there. One is Mercy, one is Holly. And at Mercy, this progression plan allows 33 seconds for the minor street phase. Is that enough time to do for whatever demand is on Mercy, for whatever phasing they've got going there? Is 33 seconds enough? And then at Holly Minor Street, is 29 seconds enough? So that's my measure of the quality of progression, is whatever intersection you're looking at here, does it provide you enough time to process the minor streets while not interrupting the major street? So hopefully that works for you. Here's sort of the worked out version of that in terms of the percent of the arterial on which each of these designs would fit without interrupting the progression band, if that makes sense. So the Throughcut design, you could see there, in one of those cases, you could put a Throughcut anywhere along the arterial and you could still have awesome signal progression both directions at 100% in that one case. And on the other hand, partial CFI and others, not so much. So I hope you're buying that as a measure of the quality of progression. Fantastic. On to the designs. Here's the comparison. Four-phase conventional design. I have the unhappy task of driving through Capitol Millbrook most every day on my way back and forth to work. Don't recommend it. Let's not build any more like it. So here, on the right side, that's basically 6 measures that I've come up with of this is very hypothetical, long range kind of stuff, but the capacity in red there, that means terrible. The conflict points in red, that means terrible. The progression in red, that means terrible. No surprise. If you know that intersection, it's unsafe, it's not efficient, and it doesn't move anybody on green. On the other hand, nobody has to drive extra distance. It doesn't take any extra right-of-way, and the pedestrian service is so-so. So that's kind of the standard against which we're comparing these other designs. Here's an offset intersection down the street on Capitol Boulevard. There's an interesting offset at Highwoods and Westinghouse, shown in the picture there. Yeah, we got rid of a couple of reds there, didn't we? You take a basic conventional intersection and split it up to be an offset. We actually probably get safer. We actually create some capacity that wasn't there before. The pedestrians get a little bit better deal. Take some extra right-of-way, you can see there. But remember the conventional intersection with 3 red, and if you create an offset, only 1. So we had, for a number of years in the state, we had projects to take offset intersections and turn them into 4-legged. Wish we could have a redo, as it turns out. Some of those probably haven't worked out too well. Offset intersections should be on our list. Partial CFI. Here's our one in Charlotte, northwest side of Charlotte, just above 485. Been open for a couple of years. Got 2 nice solid green scores there. Good for capacity, and that's really why the CFI is a contender. It does provide capacity, and it doesn't make anybody travel any extra distance. On the other hand, it takes up a lot of extra right-of-way, so that's cost and impact and difficulty of construction and maintenance, following on the previous presenters in here. It's not good for pedestrian. It's not good for progression. So there's your trade-off when you choose a CFI. The partial CFI, it's a 3-phase design because on the minor street, we still need 2 phases. Still got a left turn phase and a through phase on the minor street. So yeah, should be in the consideration where we need that extra capacity, but recognize what you're trading that for with the right-of-way, the pedestrians, and the progression. The Quadrant design, like I mentioned, guidebook out from Federal Highway a couple of years ago. We have a partial sort of quadrant intersection in the Charlotte area. This is a full version in Virginia that I'm showing you in the picture. A quadrant, also two green measures there. Excellent for capacity, excellent for pedestrians. So it's a little bit of a trade-off for against the CFI. On the other hand, the quadrant, it takes up a lot of extra right-of-way for that connector road, and not so good for the extra travel distance and for the conflict points, okay for progression. So here's the trade-offs start to become apparent here. When you're choosing one intersection form over the other, if you're in a place that's got some pedestrian demand, then CFI maybe not so much. This one starts to rise up and be a good contender. All right, here's some of the newer ones now. The CFI MUT Combo, MUT, median U-turn. And we're actually got a couple of these in design, you can see there, in Eden and in Matthews. It's got one CFI ramp, and it's got one median U-turn bulb out. And the good news is both of those are on the same leg of the intersection, so that makes this thing a little bit more constructible, and it also helps with pedestrian crossing quality. So good capacity, good for not much extra travel distance, pretty good for pedestrian. Doesn't do much for your progression up and down the major street, and conflict points not so good, extra right-of-way not so good. But you can see where this thing would be attractive and why it has been chosen in a couple of places and probably deserves good consideration in other places, keeping all those impacts just on one side and then freeing up good space for pedestrian. Partial median U-turn. Only one I know of that's been built in the world is in Boise, Idaho. If there's others out there, I'd sure like to see them. as far as I know, the one in Idaho works well. I keep applying for travel funds to go visit, but somehow that hadn't worked yet. Maybe this year. So there's more of the trade-off there. It's not so good for progression, but it's good or decent as far as I could tell in the other dimensions that I'm interested in. The way the partial median U-turn works, I hope you can tell from the diagram, it allows the left turn from the minor street, which is the north-south street on the little diagram there, but the left turn from the major street is the one that gets sent downstream, make a U-turn, and then come back to the main intersection. So it gets you down to the 3 phases, and again, treats pedestrians very well. Median U-turn is the best design for pedestrian, as far as I could tell, should be in every complete street conversation, and it makes sense that the partial median U-turn would also be a great contender anytime you think you've got a pedestrian demand. Here's the close cousin of that last one. It doesn't have a name. I don't think it's ever been built, but the obvious twist is, well, let's allow the left turns from the major street and prohibit the left turns from the minor street. So we're still down to 3 phases. Like I said, I don't know that this thing has ever been built, but got no red over there in the measures. It's mediocre at most everything as far as I can tell. Really good for pedestrian. Again, probably should be a contender anywhere we're kind of serious about the complete streets conversation. Takes a little extra right of way, takes some extra travel distance. Capacity's not as good as some of the other designs, but it doesn't really have any big negatives. So if you're in a place like that needs some capacity and you're going to have pedestrian demand, maybe this one should be among your alternatives. What am I doing here? All right, let's take a minute, look at the diagram. Northbound, so that's a minor street, northbound, everything's being redirected. So if you're a northbound minor street driver, you have to turn right. So it's like an RCI in that sense, but only that direction. All the other 3 approaches, it's all conventional. It's only the northbound that gets redirected. So we only have to build 1 bulb out, and you see where I'm going with that then. This is maybe a contender for a place that we've got trouble finding 2 bulb outs, but we've got a good spot for 1 of them. Right? So it's got three phases at the intersection. Not great for capacity. That making that one direction reroute there takes away from the capacity of the main intersection. But if we run the numbers and it can handle that relatively low capacity in the other dimensions, so you can see there it's pretty decent. Should be pretty safe. Again, only takes up one bulb out, a little bit of extra right of way. Decent for pedestrian progression, etc. All right, and now on to the one that I think has the most promise. The Throughcut is the one I think. Who am I? What do I know? My crystal ball. But I can see out in 20, 25, 30 years after we get some projects built that we'll eventually have more of these than the RCI. I think I can see that, and when we unroll the relative advantages and disadvantages of this one, maybe you'll join me in that. So the picture there is a location in Charlotte, south side of Charlotte, right near I-77. And hopefully what you can gain from the picture is we prohibit the minor street through movement. So if you're trying to go, and in this case, the major street goes east-west, the minor street is north-south. If you're trying to go from the development on the south side to the development on the north side, you're going to have to find another way. So this one, we're either going to need bulb outs to accommodate U-turns, or, as in the case in this development, there's a nice setup of backage roads, connector roads. So I don't know if it even matters here if you're coming from the south, you turn left or right, and then make a turn at the next intersection, and you can get back into the development on the north side. So we take advantage of sort of the backage roads, the connector roads there, or like I said, let's build ourselves a bulb out. Here's the other through cut that I know of in North Carolina, relatively recent, in Holly Springs, right by the Walmart. Been in there year or two maybe, long enough so that the aerial has made it to Google. And you could, one thing that jumps out at me when I look at this is the pedestrian crossing through the middle, diagonal pedestrian crossing, similar to an RCI. But again, no through movement. I don't think Walmart minds that. I don't think Walmart minds that you can't get directly from the Walmart to the Target. And do some customers mind? Maybe. But there's, again, at this place, there's enough interconnectivity where if you have to go Walmart to Target, you go left or right, you find a side street, there's another entrance in. So we're really not missing that through movement all that much at these kind of places. And the advantages are, it turns out, pretty profound. Virginia is all over this one. They didn't invent it. I don't know who did. Maybe we did with that one in Charlotte that's been there a number of years. But Virginia has latched onto it, and they, at this point, are leading the charge as far as through cuts. Here's outside of Roanoke. If you know the 220, US 220 corridor coming up out of the Triad heading toward Roanoke, their plan is to basically convert every signal along 220 into a through cut to get rid of the phases, free up that capacity, and add the safety, as you might imagine. So they're got a nice DDI in there as well. But basically through cuts at all of those intersections. Here's a slide I ripped off from them showing if you do this, the current four-phase design, the best you can do is 68% of the green for the US 220, and after you make the conversion, doing no geometry at all. This is just signals and markings, signs, traffic control devices. You get to 76% green for the major street, and that 8% matters in a corridor like 220 or in any number across North Carolina. So converting, it's their plan anyway, all of the signals on 220 from the state line up to Roanoke. And then they've also, I know they've got a bunch more planned for Northern Virginia as well. You can see their estimates of the reduction in delay compared to the current conventional signals that are there. They think that through cuts will reduce rear end crashes as well. I agree. I think when you give the main direction more green, there's going to be fewer stops. That should mean fewer conflicts and also shorter queues and preserving capacity on that important route. The fly in the ointment for through cut is pedestrian. It's tough. That is one the one aspect that we're going to have to work on as far as the through cut design. So showed you before the Holly Springs version that had the pedestrian crossing diagonal through the middle of the intersection. Nothing particularly wrong with that. I think in Holly Springs, there's hardly any pedestrian demand anyway. But for the ones that show up, trying to walk from Walmart to Target, I think we give them a path. So you can do diagonal, or my sketch here, you can do a two-stage straight across crossing. But what that means is now all of a sudden we need some width in the median to stage the people. And so the designers in the room know what that is. Is that 8 feet? Is that 10 feet? What kind of railing? What kind of push button? That's starting to be beyond me there. You know that better than I do. But there's going to have to be some width for some staging if you adopt this. Or like I said, you can do the diagonal like Holly Springs. Okay, so here's how the through cut shakes out as far as the measures go. On capacity, it is right up there. Gets a solid green, 2 left turns. It's, as far as I could tell, the same capacity as a partial CFI and as a quadrant roadway intersection. And for that matter, as a RCI and a median UTurn, some of the TwoPhase designs. So this thing brings capacity. You're freeing up green time for the main street, like we saw in that slide from Virginia. Decent for the extra travel distance. It's basically the 2 through movements that get rerouted somehow. Hopefully you're putting these at places where the minor street through is not all that heavy of a demand anyway. So when we have to reroute those movements, we're not inconveniencing thousands of drivers. Conflict points. I have a crash study of the Throughcut in Charlotte to this point. It looks like it so far is behaving from a safety point of view very similar to the surrounding conventional intersections. So that's one data point. We need a lot more. Looks at first glance like the safety is going to be pretty good for the Throughcut design. Doesn't need much extra right-of-way, if any. If you already got the connecting roads, fantastic. If you don't have those, you're going to have to build bulb outs, but we can do that. The pedestrians, that's the one maybe flying the ointment for this one. It's not an impossible crossing, but if you run the 20 flags method here, it gets some flags. There's some score there. So let's design well. Let's pick our spots carefully. And then as far as progression goes, this is really about it's as good as any full signal intersection that I know of. RCI is perfect progression. This is not RCI, but it's as good as any design that I know of that has a full signal that stops both directions of traffic on the major street. Okay, couple others to kind of round things out. We do have a couple of the reverse RCIs built across North Carolina. Here's one again from Holly Springs. There's a couple in the eastern part of the state as well. And the reverse RCI redirects the major street lefts and the minor street throughs. So we're reversing in the sense that at this design, we're allowing the minor street left. At a regular RCI, we're allowing the major street left. So there's the reverse part of it. Not good for capacity, not good for extra travel distance, for movements being redirected and having to make drive extra distance there. On the other hand, the conflict point score came up really good. The RCIs are giving us terrific safety record. It looks like the reverse RCI, I haven't seen any study of them as a whole, but the individual intersections out there look like they're doing quite well. Maybe we should commission a larger study. Extra right-of-way, pedestrians actually pretty good. That diagonal crossing through the middle there. Turns out we have a PR problem when we show up at a public meeting and tell people that's how they're going to have to cross the street. But if you actually walk it sometime, or even look at a simulation, or even run the 20 flags out, you can see it's actually not that dastardly of a way to get across the street. There's a lot worse out there. And then as far as progression goes, this thing is not great either. So it's to me, our reverse RCI is not off the table. There's some features here, but I'm hard pressed to see if we have the Throughcut as a competitor where we're going to really build that many more of these in that kind of same niche. I think the Throughcut is a really tough competitor. And then there's this. I think Mike Reese is here. Yeah, hey Mike. Worked on this with me a few years ago. We got this published. We sort of have it in mind as a response to a new development, traffic impact analysis kind of thing. But as part of a TIP project, I think it could work as well. This, in a sense, this is as we're redirecting as little as possible here. The only thing we're redirecting in this diagram is the northbound through movement. The northbound through has to make a right and then make a U at the bulb out. So we're just redirecting one movement. Everybody else gets to use the middle of the intersection like they wish. And the little note there says this is really only intended, and we ran the numbers out for this and confirmed it. You've got to have one of those situations with on the minor street, heavy demand from one direction and light demand from the other direction. Doesn't make sense if you sort of got balanced demand. If there's two heavier minor streets, this one very quickly falls apart. But if you meet that caveat, then you get some good features. You get very nice capacity, not much extra travel distance, only building one bulb out, and you're pretty decent for progression as well. So this thing, as far as I know, it's never been built. We've looked at it a few places. We should look at it some more places. Like I said, it's really light touch. I started out the presentation by saying I'm in the compromise business here. This is as compromised as I can get, right? Only redirecting one of the 12 movements without giving away the whole store. Okay, so summary, let's go build two-phase intersections where we can. They're the best. RCI, median U-turn, full CFI. We got the numbers. It is not controversial. Maybe we've still got PR issues. There's other issues, fitting the right design in the right place. But in general, you show me a spot that's got 4 approaches. I'll tell you that a two-phase design of one or the other of those is going to be the optimum from the measures that we have, from engineering measures. When the public and the media and the politicians get involved, it's a whole other story, right? Two-phase designs are the best. Yeah, sometimes the public and the media and the politicians do get involved, and we can't do what we want to do. So we're going to have to compromise, and we come in with these three-phase designs. At least 10. It looks to me like meet the sort of viability test of I can picture a place where I would put each of those with the kind of unique advantages and disadvantages. Of course, there's no perfect design. That's why we're here. If there's a perfect design, we could all go home. There isn't one. We have to be good planners and engineers and match up the right design in the right place. So rest assured, there'll still be paychecks for those of us in this business. There is no perfect design. As far as I can tell, they're all better than the standard 4-phase. That should be our sort of, to me anyway, sort of last resort, or the thing we, absolutely have to fall back on if they just won't let us do our jobs, right? But if we're more interested in safety, more interested in pedestrian movement, more interested in capacity, efficiency, probably there's going to be a better design than 4-phase conventional. And there's these trade-offs. So here's sort of measles version of those trade-offs. Just borrowing the color coding from the previous slides, trying to put them all in one place. Luckily, like they said, these slides will be available and the presentation is being recorded. So I guess what I would draw your attention to is the one column that doesn't have any red or pink, and that's that redirected minor legs. I'm sorry, redirected minor lefts. That's the partial median U-turn, and I didn't expect that to come out that way either, but that, as far as I could tell, turns out to be the one that really doesn't have any disadvantages. Everything else down the line with at least some pink down the column there, or red. Several of them you can see there with 2 or 3 reds that get maybe more difficult. So that's sort of the graphical summary. Looks like we've got time, so let's onward to an example. Completely hypothetical. I don't know where this example came from. Well, let's suppose they let us do something someday to US 15 and 501 in Chapel Hill. Now, there is a backstory. I took 2 whacks at that project and got got stopped both times, and probably others in this room with many, many more attempts at it than I made. But maybe someday they'll let us try to improve that one. So if we could restart the process and now sort of come into it with these compromises in mind, right? The best thing to do with 15501 would be to make it a complete RCI corridor, in my humble opinion. They'll never let us do that. Okay. Let's come back again and say, can we try some of these three-phase designs? Can we finesse something in there that maybe would get the approval of the local stakeholders there, be good enough for pedestrian and good enough for not needing extra right-of-way and such? So I take advantage, in the first look at it there, I take advantage of the signal spacing. Remember, I started with that, had some slides on the spacing, to use progression to my advantage and say, well, RCI, I don't care about progression because it's perfect in both directions, any spacing. But if I'm making these compromises, now the spacing becomes important. Luckily, on this corridor, and luckily a lot of them that you've got back home, you've got signals, but you run the numbers on them, they might fall out at pretty good spacings to let you do some of these things. And then I looked at it further and kind of chunked up some of the distances there and said, maybe there's like a sort of a mega spacing there, a big background. So time space diagram at those chunks, again, looking at what's available on the side street. If we want to keep traffic moving on the main street. Here's the center part of it with the spacing of the existing signals. And then here's the southern part of it. And I want to draw your attention to Willow there. You see that one, 2,200 feet from the beginning of the time-space diagram. And there's only 6 seconds of time available for the minor street at Willow. That's going to have to be RCI, right? There is no design we can pull out of our back pocket here that will process minor street vehicles of any demand if they have only 6 seconds available. So either we can revamp the whole system, change the speeds, change the cycle lengths. Those are really tough things to change. Or Willow is the one we're going to have to go back to the local stakeholders there and say, that one just fell at the wrong place. And that's the one that's going to have to be an RCI. But if you go back and look at, if you notice as I was clicking through the other ones, Willow was the only one that had that unfortunate of kind of falling in the wrong place with the wrong spacing. All right, so can we use a throughcut at those first couple of intersections? I think we can. And if we do that, compared to the conventional design, with the forecast that I had available, we get the same number of lanes, we get a nice increase in capacity, and it happens that there's interconnectivity between those first couple of intersections, Easttown North and Easttown South. Not much pedestrian demand there as far as I could tell. You tell me a reason that Throughcuts wouldn't be at least a good contender at those places. Sage, where the Wegmans just got built recently, that could stay conventional. I'd rather not. We should probably convert it. But if we're in the business of making compromise to get a project built, maybe they would enjoy that one staying conventional to get back and forth to the new Wegmans. Irwin's the RCI. Franklin, there's a bridge there. We can either keep the bridge or we can convert it. Doesn't much matter because it's going to work well either case under this scheme. Ephesus can stay conventional because it's at the right spacing. Elliott, converted to a throughcut, same number of lanes. We get a 15-point reduction in V over C ratio by using throughcut instead of conventional. So let me repeat that. No extra pavement, 0.15 better demand to capacity ratio. Willow's the one that has to be an RCI. That's going to be the tough push with the stakeholders. And then finally, Estes can stay conventional. I can get 15501 to work I think, very well, like this, if the stakeholders are willing to compromise on Willow, that's the one that just fell at the wrong spacing, and if they're willing to go with Throughcut at some of these other places. And I hope that's a compromise that we, DOT, on behalf of all the stakeholders, and not just the locals, but the people using 15501 to get to Pittsboro, hope they can live with it as well if we're able to offer that kind of mobility. So that's where I'm heading with these three-phase designs. Okay, that is through my slides. We got a few minutes for questions. Certainly don't want to hold up your lunch, but I want to talk intersections anytime, so have at it. Let me know.
Quick question on a driver's expectations.
Yep.
You know, my experience is it's very difficult to turn right to turn left, like from a minor street onto a major or whatever. I didn't see that really as one of your criteria, maybe the movement redirection, but if you have a corridor with all different types, you don't know whether to be right or left to go straight or through. And do you look at that as well?
Yeah, thank you. Driver expectations. Yes, we certainly should look at that. Certainly should matter. Several of these designs have the advantage of not giving drivers a choice. RCI is great at that, right? RCI, minor street, you got to turn right. That's it, unless you're going to violate 10 different laws and jump over curbs. You got to turn right, and then you decide where to go after that. And several of these designs have that same feature, where there's just no other choice. Other of these designs, yes, I'm presuming that the traffic control devices are all done well. Signs, signals, markings. We've got channelization, islands, all those kind of cues that drivers could use as well. And we do have to be concerned with the pattern. You're right. It's better left goes left and right goes right. Even if they get redirected, even if that movement happens earlier or later, it's probably still better. At least they're going in that direction. So yes, we've got to be conscious of that. One other thought is especially median U-turn design. I grew up in Michigan. Median U-turn was the way I learned to drive. I was shocked when I went to the other 49 states and discovered they don't make left turns the same way as we do back there. Drivers get used to it, right? And median U-turn is safer. A new paper just came out last year's TRB with a crash modification factor 0.6. You take out your conventional design, put in a median U-turn, you prevent 40% of the crashes, all else being equal. And a median U-turn is a relatively difficult one to drive. It messes with your driver expectations. So is that a way of saying driver expectations are overrated? Perhaps. The numbers show that once the drivers get used to it, these designs work safely. Thanks.
For an offset intersection, what factor do you use to determine the minimum spacing?
Yeah, good, thanks. Luckily, we just finished up a research project on that. Within the last couple of years, ITRI conducted it for NCDOT. And so I would direct you to the R&D website and type in offset intersection. The report will come up there. And there definitely is a minimum value. It's roughly 500 feet that you need between the two offsetting streets because you need to store vehicles in between. And then there's some distance that which it's too far and we're causing too much inefficiency. So there's a sweet spot there for sure, 500 to 800 or so, at which these work really well. And it also matters in the offset whether we're going right then left or left then right. And again, the research report, we really wanted them to dig into that aspect. They did. They came back out with some recommendations. And of course, like all of this stuff, it depends on your demands. of which of those patterns is better. So head to the research report to look at the spacing and the directionality there, and a lot of other facts and figures about offset intersections. Yeah, we really should do more of those. For sure, what that research confirmed for me, I think a lot of other people, is we should for sure stop with the projects that take a perfectly good offset intersection and convert it into a four-legged. That's just, the research showed that's throwing good money after bad at the right phase. Let's not do any more of those. How aggressive we should be on our conversions? Yeah, dig into the details and the numbers there. Thanks. Good. Others?
Great presentation, by the way. Has there been any studies, and I know this is a long-fetched, I'm stretching here, has there been any studies on how autonomous vehicles are going to manipulate these intersections? Is it going to be more efficient? And how is the navigation system going to be trained to navigate such intersections?
Yeah, good, thanks. I wrote a problem statement on that very topic last year, and it did not get funded. So those of you on the committee, come on, help me out here. I think that's an awesome topic. I want to know that answer myself. My guess is, again, Joe's crystal ball, whatever it's worth, that automated vehicles will be just fine because the intersections don't move. They don't change. We build them once and they stay there for 100 years afterward. So all the automated vehicle needs is the map and then a direction of how to get through this spot. And that's something I think we can code in pretty easily. I'm more concerned actually with automated vehicles through work zones and such at things that do move. Whereas we can't just code in the map and let the program do its thing. But an intersection and interchange, for that matter, the driver's out of it. So the question about driver expectations, the machine has no expectations. It just needs a direction. And if we coded the map correctly, which I presume Tesla and Google and Uber and all those companies will do that because they'll get sued if they don't, that will be okay in that aspect. But I did think enough of it to write that problem statement. It's still a good question out there. Thanks. Well, eventually you're correct. The comment was we won't need traffic signals, and again, maybe further out a few years, I agree with that. We'll probably get to a stage where the automated vehicles will chunk up in platoons and be able to move through a conflicting spot without interfering with the conflicting platoon. So I hope to live to see that. Good. Other questions?
For the presentation, Dr. Hammer, quick question. The flag numbers that you had up on the slides for various types of intersections, is that tied to pedestrian refuge islands, or like how is the measure?
Yeah, good. A little bit more detail on that. So the number of flags is from the procedure in NCHRP report 948 that's published 2020, I think, or early 21. Flags are bad things. So as an analyst, and all of us could get trained in how to do the flag procedure, it's not difficult. But you look at an intersection, look at each of the 4 crosswalks and each of the 12 bicyclist movements, left through and right from each approach. And basically there's 20 aspects that you're looking at and making a judgment. It's a yes or no judgment. Is this thing, like I said before, does it cause discomfort? Or does it cause a less safe environment? And then you score at that. So I guess it's not yes or no. It's no flag, yellow flag, red flag. But 20 specific things you look at for each crosswalk or each bicyclist movement. It's not difficult, and the beauty of it is not difficult, but it's consistent. That if I scored the 20 flags and you scored the 20 flags, we should come up with the same score. They're very specific criteria, sometimes numeric. How much turning demand is there interfering with that pedestrian making that movement? Again, that should not be controversial. I hope you could tell I love the 20 flags method. Consistent, repeatable, bicyclist and pedestrian, and a level playing field. Let's get the emotion out of it. Sometimes the advocates out there want to make it a very emotional issue, and what are you trying to do to us, and you don't like us, and I'm an engineer. I want to bring it back out of the emotion, back into numbers, back into scores, and that's what the 20 flag method does for us, I think. Thank you. Good.
Thanks, Dr. Hummer. A lot of these intersections you're proposing, I guess, kind of assume that there's a median there. You're in a divided highway situation. If we're widening an existing street that doesn't have that, is there any, advice on how to? Do you want to force that into that? Do you, how do you propose we design our roads now? Should we be looking to do more divided highways and boulevard kind of streets?
Yeah, great. Thank you. Excellent. So two responses. One response is undivided 4-lane cross-section, which is the worst cross-section that we've ever invented. There's still something like 800 miles of that on state-owned roads across North Carolina. We need to get to work to eliminate all of those, right? I mean, they're just nasty, dangerous. Crash rates twice as much as any other cross-section, right? I mean, why are we doing that? So, yes, median of some sort everywhere, but I'm working on a paper. Invite me back next year, I'll present it, on what to do about undivided 4-lane. I got some ideas. If it's a low demand, of course, we do a road diet, 4-to-3 conversion. But if it's a higher demand, we've always struggled with that. Widening is a dastardly project. Nobody likes it. The community's up in arms. What can we do? Maybe narrow median, maybe just enough median in a few places where we really need it. Pick our spots. But it's a tough problem on the undivided 4-lane. If we've already got a 5th lane, a left turn lane, or some type of median there, then it's a question of, well, we just need enough in the right places. So my diagrams take liberties with that, but as designers, we can work with that. You can narrow down in some places where you've got trouble and then widen out in other places where you need the diameter to allow the U-turn, to allow the bulb out or whatever. So pick and choose, and the same thing for pedestrian crossing. The throughcut design there, whatever we need, 8 or 10 feet of refuge in the middle. Well, where do we need that? I showed it right at the intersection. It really doesn't have to be. If we've got a 10-foot available one lot away, can we do just a widening there? Let's be creative about that. Again, the whole idea here is make the compromises we need to get a project done. Perfect is the enemy of the good. If we get 90% of the ideal, we're going to improve the situation for a lot of people out there. So, pick our spots. We do need median, but not everywhere. Thanks.
I think we have time for one last question before lunch. Anyone else?
Like the question is, what's for lunch?
Well, let's give Dr. Hummer a big round of applause.